So question 12, which is on trigonometric identities and double angle formulae. So part A says prove that 1 minus cos 2 theta is equal to that there, tan theta over sine 2 theta. Now my gut reaction with this is to focus on just one single term there, which requires a sine on the top and a cos on the bottom. So let's just remember that tan equals sine theta over cos theta. So that's my starting point. So let's try and get sine on the numerator in this answer. So we've got 1 minus cos of 2 theta. And this just involves your trig identities, which is 1 minus, and cos 2 theta is 1 minus 2 sine squared theta. So when we take out the bracket there, we've got 1 minus 1, which is 0, then double minus 2 sine squared theta, which is positive 2 sine squared theta. So that still doesn't look like tan theta sine 2 theta. But this is the next step. Let's try and force a tan in there. So we can't really multiply by anything other than 1, otherwise we'll change the value of what we've got and we can't have that. So what we're going to do, we're going to times by 1, but in this really clever way. Cos theta over cos theta. So that in turn is equal to 2 sine squared theta cos theta over cos theta. And if we write it in this way, 2 sine theta over cos theta times sine theta cos theta. And you have a look at that to convince yourself that that's true, that that's equal to everything that we've written before. Okay, so that becomes tan theta times 2 sine theta cos theta. And again, this involves knowing your trig identities. That then becomes tan theta sine 2 theta. And that's part 1 done. So part B, it says hence solve for those limits there, minus pi over 2 to pi over 2, this equation here. So sec squared x minus 5, sec squared x minus 5, 1 minus cos 2x equals 3 tan squared x sine 2x. Tan theta sine 2 theta. And that's part 1 done. So part B, it says hence solve for those limits there, minus pi over 2 to pi over 2, this equation here. So sec squared x minus 5, sec squared x minus 5, 1 minus cos 2x equals 3 tan squared x sine 2x. So this then implies that sec squared x minus 5 times, and this bracket here, from the previous work we've done, we know it is equal to tan x sine 2x. So tan x sine 2x equals 3 tan squared x sine 2x. So from this point, what we would do is divide by both sides by tan x sine 2x. But we've got to be sure that they're not equal to 0. So can tan x sine 2x equal 0? Well, yes, it certainly can if x equals 0. So x equals 0 is a solution. So now that we've considered the 0 solution, we might as well now divide by tan x sine 2x. So, which means that's sec squared x minus 5. And we're dividing both sides by tan x sine 2x, which leaves on the right hand side 3 tan x. And now we're left with a hidden quadratic. So that means that sec squared x minus 5 equals 3 tan x. Now using the trig identities, So I've got sine squared theta plus cos squared theta identical to 1. If I divide by cos squared theta, that gives me tan squared theta plus 1 is identical to sec squared theta. So that implies that tan squared theta plus 1 minus 5 take 3 tan x equals 0, and just delete that there. That should say x rather than theta, which means that tan squared x minus 3 tan x minus 4 equals 0, which implies that factorizing it, tan x, then we've got minus 4 and plus 1, which means that tan x equals 4 or tan x equals minus 1. So putting those into a calculator and making sure it's in radians mode. So we've got the arctan of 4, which is 1.3258. So x equals arctan, or tan to the minus 1 you could write as well, of 4 equals 1.3258, or x equals arctan of minus 1, which is minus pi over 4. So, just quickly drawing a diagram, nice rough diagram there. So it was between minus pi over 2 and pi over 2 were the limits. So tan looks like that for those, roughly. So we've got 1.3258, which wouldn't give rise to any corresponding angle. And we've got minus pi over 4, which again only cuts once. Therefore, the angles we worked out so far overall were x equals 0, 1 point, and let's have a look at whether it wanted a certain number of decimal places. 3 decimal places where appropriate. So 1.326, and then minus pi over 4 as an exact answer. It's not appropriate to round an exact answer. So there's the 3 solutions, and that's the question done. But the key point here, the hard part, was recognising before dividing by tan x sine 2x that a solution existed at x equals 0. If we divide by it without recognising that, we'll lose this 0 solution altogether. So that was the trick in that question. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.